Everyone, and welcome to this IB problem solver video. What I want to do is take a kind of big problem in IB physics and then break it down and look at how we're going to solve that problem, and look at the steps along the way, some strategies for helping you solve. In this case, we're looking at a problem on combining uncertainties, which I'm sure is not everyone's favorite subject. It's quite a dry one. However, it's a really important skill when we're doing experiments, and it's one we have to be confident with. So here we go. We're being asked in the question to calculate the density of aluminium. We're given the mass, and we're given the size of the length of the cube. We're being told in our command here to express the answer to an appropriate number of significant figures, and obviously to give its uncertainty as well. And that's why this question is actually 5 marks. And you wouldn't normally get 5 marks for calculating a density, so really the additional marks there are for the uncertainty and for the significant figure work that you're going to have to do. As you might expect, the first step on any kind of problem like this is simply to calculate the quantity that we're being asked. We're being asked for the density, so let's do that. Density is mass divided by volume. We know the mass, but we don't know the volume. However, we do know that it's a cube with a length of 6 centimeters, and so therefore we should be aware that volume of cubes is L cubed. And we can then put in our L value into the equation, and we've got m over L cubed. It comes out as 2.685. Now, I've been slightly careless with my significant figures there. I've not included units. I'm being a bit lazy. My advice at this stage is to keep things to quite a high number of significant figures, as these will be reduced down at a later stage, and we'll talk about that towards the end of the problem. In this question, we are dividing, we're taking the ratio of m to v, and so in order to calculate the uncertainty, we're going to have to start by calculating the percentage uncertainty in the density. The reason for this is because when we have got two numbers and we divide them, then the way we work out the uncertainties is by adding together the percentage uncertainties and then calculating from there. So it's a slightly more complicated approach. I'm going to show you all my working just now. It's a bit messy. I would normally do this vertically, however I'm a bit challenged for space, as you can see. But we'll just work from left to right. We've got the percentage uncertainty in the density, that's delta rho over rho, is equal to the percentage uncertainty in the mass plus the percentage uncertainty in the volume. Percentage uncertainty in mass, don't need to worry about that. However, we do need to worry about our volume because we don't know that directly in the question. We know L, not V, so therefore our V's get replaced with L cubed. Now the tricky bit here is thinking about this delta L cubed, because we don't know the percentage uncertainty in L cubed, we only know the uncertainties in L. However, you should be aware of the relationship, which is that delta A to the n divided by A to the n, that's the percentage uncertainty in A to the n, is just n multiplied the percentage uncertainty in A. And so therefore, we can replace my delta L cubed over L cubed by 3 times delta L. And that is a key tool which gets reused in many of these kind of problems. So be aware of that. As soon as you see something cubed, something squared, something to the power of half, we need to remember our relationship, which is in red there. Delta A to the n is equal to n times n times the percentage uncertainty in A. Assuming we're okay with that, all we have to do is put in our numbers. 10 divided by 680, that's the percentage uncertainty in the mass. And 3 times 0.1 divided by 6.0, that's 3 times the percentage uncertainty in L. And we come out with the number 0.0647. Now again, I've given a lot of significant figures there. We'll discuss that a little bit more in a second. I would say this is the point where most people get to. They say they manage to do the calculation, they get to this 0.0647, but it's important to remember what we have calculated there. We have calculated the percentage uncertainty in rho, but we don't want to leave it as a percentage. We want to then turn that into an absolute uncertainty. We want to calculate the uncertainty, the absolute uncertainty in rho. How do we do that? Well, it's actually fairly simple. All we do is take our value of the percentage uncertainty and our value of rho and multiply them. And we end up with a value which is 0.173. Now, apologies for the typo here, this should say 1 significant figure. We then need to change delta rho to 1 significant figure. Okay, 0.173 becomes 0.2 according to our one significant figure. And that is another step that will get you about a mark in an exam, all right? However, it is one that people forget very, very quickly. The last thing that we have to do is modify our value of rho where necessary. Now, if you see here, we're giving our value of the uncertainty to one significant figure. That's one decimal place. And so my value up at the top there, 2.685, has to be changed in order to reflect that. In this case, I'm going to have to give my density to 1 decimal place. So that means my density becomes 2.7 plus minus 0.2 grams per centimeters cubed. Okay, the idea here is that after you've calculated your value of the uncertainty, you then need to revisit your value of the density and modify it such that the uncertainty makes sense with the value you've presented. So in this case, I could not present 2.685 plus minus 0.2. I have to change that so that the decimal places match, and then therefore I've got 2.7 plus minus 0.2. So those are our steps. Firstly, calculate the number that you're going to calculate. Then calculate the percentage uncertainty if you need to. Then calculate the uncertainty. Change the uncertainty to one significant figure, not the two that I've written here. And then change the value of the density if necessary. That's our 5 steps towards getting 5 marks in quite a horrible question at IB Physics. I hope that's clear. If you'd like to ask me any questions, please feel free to do so. I'm more than happy to answer you those questions.